Okay, we are going to go over the CBA 2. This is going to be the review for that assessment to go ahead and help you get things ready and to help you review all the concepts before we take the CBA. Okay, so this review is going to cover the key concepts related to linear functions, including domain and range, rates of change, and interpreting different graphs. You'll want to familiarize yourself with the questions and the concepts to prepare effectively for this CBA. So a few things that I want you to go ahead and look at. So first thing is domain and range. Okay, remember those are important topics. So the domain is going to be the set of all possible input values. And remember, your input values are also referred to as X values. Range is going to be the set of all possible output values. And remember, those are your Y values. So if I'm going to go ahead and create a little graph, this axis is my Y axis. Okay, the vertical is my Y and the horizontal is my X. Also, a way I can go ahead and write this is I'm going to write domain. And then I'm going to put range vertically. That just kind of helps me remember my domain is the X and my range is the Y. Make sure you pay attention to exactly what they're asking, because sometimes they will ask for the range and then the domain. Sometimes they will flip up the order that we review those words. And if they do that, sometimes that might kind of confuse us. So it always helps to write it off to the side. Maybe you actually even want to label, put a little arrow here, and that's domain, and then, put an arrow to the Y-axis and know that one is going to be your range as well. Something else I want you to go ahead and review and look over is rate of change. So the rate of change describes how one variable changes in relationship to another. For linear functions, it's going to be constant. So rate of change. And I want you to remember that rate of change we could also call slope. Okay, and remember, if I have something like mx, where m is the number in front of my x, the slope is going to be that value that is in front of the x. Okay, so let's say number in front of the x. Okay, so if I have an equation and I'm looking at it and it says what's the rate of change, they are talking about the slope. Something else that is going to be important to review is interpreting graphs. So you want to be able to understand how to read graphs and determine properties such as slopes, intercepts, and solution sets. Okay, so a couple of things here. So slope, intercept, right? That is where it crosses the X or the Y line. And then solution sets are going to be part of the solution. So let's do some examples here. So y equals mx plus b. On that equation, the slope is going to be my m. Okay, this plus b is going to be my y intercept. And a solution set. So if I have just a straight line, a straight solid line, right, or a linear equation, if it's solid line, it is going to go ahead and be any dot on there, right, a part of that solid line. So part of line if it's solid. Now, if I was graphing an inequality where I have the dashed line, it is not going to include that dashed line, but it would be part, I'll call it shaded area. So if I'm graphing an inequality, right, so let's little graph here, let's say this is my inequality. Anything down here, anything in the shaded area, right, would be a solution to that. Do that arrow in black. Also, since I drew a solid line, that any point on that line or any point in the shaded area would be part of the solution set, or would be a solution to that inequality. And the last kind of a major point on this exam is going to be direct proportionality. So when one variable is directly proportional to another, it can be expressed as y equals kx, where k is the constant. So a few things to remember. K equals y over x from the given information. So if I'm given a y value of 10 and an x value of 2, and it's saying what is the constant, or write an equation, right? So let's say if I have a y value of 10 and 2 is my x value, and it says, what is k, right? Or what is the constant? You're going to do 10 over 2. It's going to simplify to 5. Your equation, so k is 5, but your equation is going to be y equals 5x. Okay, that's a little example on that. Now, if you're reading when one variable is directly proportional to another, so when you read this portion of the information, let's see if I can get a better color here. So when you read it this way, okay, so let's say read it like this. Okay, here's my example. You're going to go ahead and go, okay, so when one variable is directly proportional, little division sign, to another. So we're going to go one variable over another. That is how you're going to go ahead and set this up to figure out what k is. If it says directly proportional to something, this is your denominator, this is your numerator. So let's look at some of the sample questions that I've given you here. So one says, range of a linear function. So we are going to go ahead and look at range. And again, range, I want you to remember that is the y value. Okay, so remember what those vocabulary words are talking about. So when analyzing, be able to identify the range of a graph or a description. So for example, if given the range is greater than or equal to -2 and less than 3, ensure you understand the notation used. So first off, let's kind of go ahead and give him a little graph to see what that looks like. So here's my graph, here's my x-axis and my y-axis. I know the range is talking, that's going to be my y-axis, greater than or equal to -2. So let's write the notation out here. I have y greater than or equal to -2. So all the way down here at -2, I would have a closed circle because it's or equal to. And then y is going to be less than, right? Less than here, less than sign, 3. So less than 3. So up here at 3, I would have an open circle. And I would go ahead and shade everything in between that. So I would have a, this is just a solid, let's just pretend that's just a solid line, okay? This is it graphed on a graph. Here is the notation. Now, most likely, I won't see it as a straight line right here on the y-axis. It might be slanted off here or somewhere else. I'm just going to have to remember to move the information to the y-axis to help me kind of pull my highest and my lowest values that y can be. Okay, so graphing interpretations. When analyzing graphs describing linear functions, determine which graph aligns with the given inequalities or equations. So an example I'm going to give you here. Let's say I was given something like 2y is less than 2x plus 4. And I have a bunch of different graphs to choose from. And it says, which graph is expressed in this inequality? Well, first thing I will have to do, okay, if I ever have anything that I have to figure out either match to the graph or to graph fit, I will need to solve for y. I want it y alone on a side. So I might have more steps I have to do. I might have less steps I have to do sometimes. But the first thing you want to do is solve for y. So looking at this inequality here, I want to get y alone. Well, you notice there's a 2 is my coefficient of the y, but I want just y. So I need to divide both sides by 2. Okay, that'll cancel out, leaving me y is less than 2 over 2x plus 4 over 2. I need to continue to simplify this side, right? I just moved this over here. This means the same as this, but I now need to keep simplifying. So let's say y is less than 2 over 2. We'll simplify it to 1, so I don't need to write it. I'm just going to say x plus 4 over 2 simplifies to 2. So there is the simplified inequality. Okay, so this one really means this. Now I can graph it. And once I can graph it, I can kind of figure out which one is going to look like it. So I need to graph, I'm going to write it again over here. Y is less than x plus 2. Here is my x and my y axis. Now my y-intercept is going to be at 2, so I'm going to go up to 1, we'll call it right here, up to 2. I would put a dot. Okay, let's even mark him here. That's 2 on my there. From this notation right here, so y is less than, I'm going to have a dashed line. So on him, on this one, is going to be a dashed line. Okay, my slope is going to be 1, so I'm going to go up 1 over 1, up 1 over 1. It would be kind of a more specific graph if I actually had all the little grids, but I don't. And now after I graph that line, right, I graphed this line, I still need to graph y is less than this. So if y is less than this, I'm going to shade everything below that line. So a solution set for this graph would be anywhere in the shaded area. It wouldn't be any point over here. It wouldn't be on the line because my line is dashed. It would only be in the shaded area. Rate of change in context. So when given real scenarios like the football player sprinting, calculate the range based on context, or like time versus distance. So rate of change, when you read that word, I want you to remember that you are dealing with the slope. Okay, slope is always going to be rise over run. Okay, so up and down, over left and right. Also, if you do not kind of have an equation to pull from, and maybe you just have a table with 2 information that you can kind of pull 2 points from, you can always go y2 minus y1 over x2 minus x1. And that is going to give you your slope. And then table analysis. So let's say you have some data, okay? I want you to be able to interpret data from a table to find the rate of change. For example, if the height increases by 16 inches every 2 steps, find the rate per step. Okay, a couple information here I want you to see. Rate per step, this right here, okay, that information is telling you that is going to be your denominator. Okay, so that is going to be your denominator of the information. And I know that the height increases 16 inches every 2 steps. And I know the rate per step is my denominator. So I'm going to have inches over steps. So we're going to go 16 over 2. which is going to simplify to 8 inches per step. Okay, graphing equations. For equations like, so if I'm given y equals -4 times x plus 4 minus 3, you need to understand how to convert this to slope-intercept form to identify the correct graph. So let's say I'm given a bunch of graphs, and I have this equation, and it says, which equation matches this? I cannot figure this out unless I change it to slope-intercept form, okay? I already have a y equals on this side, but I need to move this part over, or to change this to slope-intercept form. And remember, slope-intercept form is y equals mx plus b, where m is going to be my slope and b is going to be my y-intercept. So I have this equation here, so let me rewrite it. Y equals -4 parentheses x plus 4 minus 3. The first thing I want you to do is look at it and go, oh, I need to distribute. So you're going to go -4 times x, and you're going to get -4x. -4 times 4 is going to give you -16, and then you're going to bring the -3 down. Now, I'm going to go ahead and combine any like terms that I have, and I have a constant here and a constant here. Since there's no variable connected to the 16 or the 3, I can combine those two. So -16 minus 3 is going to give me -19, and just bring the rest of the information down. There is the equation for that, for a graph that I'm looking for. So at this point, I have two choices. I can go ahead and put this into my calculator, find the graph that matches, or I can just probably look at this equation and figure out which graph would match it the best. And the easiest way is, because I know slope-intercept and what the m and the b stand for, that it might be the easiest to figure out. So first off, I'm going to look at this and go, okay, I have a negative slope, right? So I know my slope is going to go down. Well, where is it going to cross my y line? Well, it's going to cross at -19. So somewhere all the way down here, let's just say this, all the way down to -19 would be there. I have a negative slope, so the line is still, again, from left to right is going to go down. But the slope needs to be 4, right? -4. So I'm going to go up 4 over 1, put a dot there. So the line is going to look something like this, and hopefully the graphs that you have to choose from actually have a grid where you can count this information out. And this then would be the graph that fits. So again, we're looking for something that has a slope of -4 and a y-intercept of -19. So solution sets for inequalities. You need to be able to identify points that satisfy inequalities both graphically and numerically. So a couple points on that, right? So solution sets could be a set of numbers. And satisfy inequalities at this point would be like in the shaded section, okay? So right here we're talking about in shaded section or on a solid line. And remember, sometimes you might see a test question where it gives you the inequality, but it didn't shade it. So you are going to have to figure out what part of that line is really shaded, right? Do they shade above the line? Do they shade below the line? Is the line supposed to be, solid? Maybe it's supposed to be dashed. We don't know. So you are going to have to go ahead sometimes and convert information to figure out where it's shaded. And now where it says numerically sometimes right here, they mean they're going to give us maybe as an ordered pair. So maybe they're going to say, they give us a graph, it has a shaded area, and it says, you know, is 1, 3 a solution to this graph? And you would have to like plot the point, you know, find on the x-axis, go over 1, go up 3. Okay, this point right here, does it fall in the shaded region or does it not? Okay, and the last kind of sample example thing I want to point out here is horizontal and vertical lines. They do trick us sometimes with these. So horizontal, I want you to remember, is left to right, and vertical is going to be up and down. Okay, so you need to understand the significance of equations like y equals 3, which is going to be horizontal, and x equals 5, which is vertical. So let me give you a little kind of drawn graph example. So here's my x-axis, here's my y. So y equals 3. I am on the y-axis, right? I go up to 3, and it is going to be, a horizontal line. Okay, going right there through that point 3. Again, that should be going right here through that point 3. So that is a horizontal line. Now, if I have something like x equals 5, well, I can't put that into my calculator because my calculator doesn't really graph x lines for me, but we can figure out how to do it. So we're going to go over here on x, on the x-axis. We're going to go over 5, and then we're going to draw that vertical line. So this one would be x equals 5. This line right here is y equals 3. I want to point out to you real quick. If I have something like y equals 3, right, this is going to cross the y-axis. If I have something like x equals 5, if it only has x equals, and there's no y anywhere on here, it will not cross the y-axis. It will only cross the x-axis, right? So x equals, it says, go on the x-axis, find that number, draw a line, okay? This one says, go to the y-axis, find that number, draw a line. I'm only crossing the y on a y equals. I'm only crossing the x on a x equals. Now, notice how there's no x values here, so I don't cross the x at all. Also, I want you to go ahead and kind of remember the slope of those lines. So on a x equals, it is going to be an up and down line, right? It's a vertical line, so it is going to be undefined is my slope. On a y equals, it is going to be a 0 slope. So maybe over here we put a little note too that the letter of the graph is the only line it crosses on those. Okay, so that helps us if I need, to make lines that are parallel or perpendicular to these, right? Like we kind of know, we can kind of visualize what they look like here first. So some tips for success, right? Some things that we should probably do to go ahead and help us study and get ready for the CBA. So practice graphing, be comfortable sketching graphs for given equations, and identify key features like intercepts, okay? So remember key features like intercepts. Review linear equations. Know how to convert between different forms of linear equations. So slope, intercept, or standard, right? Know which one to use, how to convert between the two of them. So how to convert, right? Kind of identify key up here. Understand proportional relationships. Be ready to solve problems involving direct proportions. So you're going to have things like y equals kx. Okay, those are direct proportions. It doesn't have a plus b. We know this graph right here will go through the origin. Examine examples. So review similar examples of problems to solidify your understanding of each concept. Look at the example problems I have provided in this packet. Do them, okay? Practice them. They will absolutely help. If you want to go ahead and pause the video right now and work on the practice problems and then come back to the explanation, you can, or you can continue with these practice problems, but I will not be doing the last page of practice problems with you here in this video. That is for you to do on your own. Okay, what is the domain and range of the function shown on the graph? So I have two graphs shown, so let's go domain, that one, and then range. I'm just going to label them range. Okay, so we remember that my domain is X and my range is Y. So dealing with my domain, let's start with the domain on this graph. I have just points. I don't have any lines. So remember, my domain is my X, so I want to take this value and kind of squish it against the X value and see what I get. Well, this dot falls on 5. Okay, this one's on 5, this one falls on 4, this one falls at 1, and this guy falls at -2. So my domain for this function would be -2, 1, 4, and 5. I write it like this with just the individual numbers and not a sliding because they are just individual dots. They are not a line. Now my range for these, so let's take those dots and squish them against the y-axis. There'd be a dot there, there'd be a dot there, this dot would be over here. So now the range for this information would be -4, -1, 2, and 3. So there is my domain and my range for this graph. And if you remember, this is called discrete information. Now looking at the one to the right, I have a line. So I'm going to have some continuous information. Again, my domain, I have an X, and my range, I have a Y. Well, since I have the line, right? So let's see, my domain, I have X here. X can be, starts here and then it goes all these values, right? This arrow tells me it's going to keep going this direction. So it starts at 2, but it has an open circle, so it can't be 2. So X is going to be greater than 2. And if it keeps going, I'm just going to leave this open right here as X, okay? I don't need to say on to infinity. We can just leave it. X is going to be greater. Any number greater works. And if I were to go ahead and take that down and squish against the X's, I would have an open circle here, and my line would continue to go this direction for my domain. Now my range is my Y. So let's start at the top. It is going to be right about there. Between 4 and 6 is probably about 5. It can be there because that's a solid line, so it could be anything this direction. So Y on here is going to be equal to, because this is what a solid line is, or less than 5. So Y is less than or equal to 5. Okay, look at this one. So given a table of values, how do you determine the rate of change? So the table shows the linear relationship between the total amount paid and the number of apples purchased. What is the price paid with respect to the number of apples purchased? So a couple things we're looking at here. What is the price paid with respect to the number of apples purchased? So that tells us I'm going to have price paid over number of apples. Then if I look at my table, I can say, oh, well, I can make this an ordered pair. 1.5 over 2 will simplify to 0.75. So 75 cents per apple. Okay, on this one, there's only 2. I miswrote when I wrote those. Okay, so the graph of the line 8x plus 2y equals 20 is shown, right? So they graph that line. which graph represents which graph represents a solution to the inequality. So again, this is the same as that line, but I don't know what side to shade. So I need to do some math to figure out where I should be shading. So let's go ahead and write this out. 8x plus 2y is less than 20. First thing I want to do, or actually the main thing I need to do, is I want to go ahead and solve for y, right? That is the important, that's what I want to do. I need to get y alone. So, looking at what I have, let's subtract 8x from both sides. That will cancel. I'm going to rewrite the inequality. So 2y is less than negative 8x plus 20. Next step, I still need to get y alone, and y is not alone yet. So I have 2y. So I need to go ahead and divide both sides by 2. That will cancel. Y is less than negative 8 over 2x plus 20 over 2. Almost done, but I can simplify those two fractions. So y is less than negative 8 over 2 is going to be negative 4x plus 20 over 2 is going to simplify to 10. And I can notice, okay, yeah, so here's my y-intercept, right? I have 10 here. Negative 4, oh yeah, that looks about a negative 4 slope. That makes sense. Now, looking at this right here, this tells us, okay, so let's label this part. So this right here was my y-intercept. This told me what my slope was. And this part right here, this very important part right here, tells me to shade below the line. Y is going to be less than. So this tells us to below the line. So everything I would shade below this line. Here's my line right here, right? I would shade everything below my line. So all of this, everything down here would be shaded. Well, guess what the 2 points are that fall below there? This one and this one. I want to point out that on this inequality, right, there's no line underneath of it, so I couldn't pick the dot on the line because technically, no, this should be a dashed line. But any point, my pen again. So any point in there is a solution, okay? Any point in there is going to be a solution to that inequality. Any point in the shaded region. Okay, so how do you find the x and the y-intercepts of a linear equation? So when you look at this, I want you to remember that the x-intercepts are also called zeros. I don't know why it's not writing it out there. There you go. Also, okay, and then y-intercepts as well, right? Also, if you need to write yourself a graph, write yourself a graph. This is the x-axis, this is the y-axis. So, let's go. Label the x's. Let's label the y's. So the x, where does it cross this x-axis? Right here. Okay, right there. And that looks to be about -4, 0. Look on the next one. Where does it cross the x-axis? Right about here. That looks about -6, 0. Now what about the y? So on the first graph, it crosses here. And if you zoom in, you're going to see that's going to be probably about 0, 12. And then the second graph right there is where it crosses the y. It's going to be about 0, -2. So make sure that you go through the concepts, practice them to help reinforce your understanding on all of it. You also have all the notes provided from all the other lessons before that are in the online notebook. Please, please, please review those. And the next 2 pages are for your practice of all the concepts.